Let us discuss electroless plating process. First of all, we see what is plating process. Any process used to protect, improve the appearance, or increase the corrosion protection, conductivity, or solderability of the substrate material is called plating. There are there are two type of plating process. One is electroplating, second is electroless plating. First, we see what is electroplating. Uh, in electroplating, the metal ions migrates via solution from positive electrode to negative electrode called cathode. Here the workpiece must be maintained at negative potential, whereas the metal to be coated as to be placed as positive electrode. For example, in gold plating, we use gold metal as positive electrode and metal to be coated. For example, copper or brass is to be made as negative electrode. So we can plate gold over brass or copper. Here the bath used in the case of gold plating is potassium cyanide. Similarly, we can coat nickel over iron using nickel sulfate electrolyte, and graphite electrode is made as positive electrode, and the workpiece iron workpiece is placed as negative electrode. So we can coat nickel from solution as Ni2 plus from solution is can be deposited on the workpiece. Let us see the procedures. The four procedures are involved. First, cleaning of the metal surface. Second is undercoat deposit. First, for example, if you want to coat nickel over iron, first you have to coat some copper over the iron surface. Over that, we have to coat nickel. So undercoat deposits are required. Then final deposit is made over the undercoat, and we have to inspect the sample. These are the procedures in to be adapted in plating process. Let us see the difference between electroplating and electroless plating. Electroplating uses electrical energy, whereas electroless plating is done without using electrical energy. Electroplating overall fast deposition, high throughput in electroplating, whereas electroless plating we can use we know electricity is required. The application metallic as well as non-metallic parts can be coated. For example, ceramic or plastic parts can be coated with the metals. Ability to achieve uniform coating, here the coating is better and uniform, whereas electroplating is not much uniform. Generally, electroplating is more applicable to metallic parts that need to be produced cost effectively in high volume. For example, automobile parts, for example, bike handle, etc., are usually iron is usually coated with nickel, and such coating is production is required in larger scale. In such case, we go for electroplating for the so and let us see the electroless plating on the other hand is suited for parts requiring high uniformity uh, and plating of non-metallic parts such as ceramics, etc. Silvering of mirror is an example for electroless plating. The silvering of mirror has been invented in 10th century, and it's one of the age-old process. Alchemists were doing silvering of mirror from 10th century, and silvering of mirror is done by taking silver nitrate solution and formaldehyde, and it is historically first kind of electroless plating technology. Electroplating were developed only after in discovery of electricity, after development of battery technology, etc. in 18th century. Let us discuss the samples, which are some samples which are made by electroless plating. For example, this printing is actually made on plastic with the electroless nickel plating. This is a laptop computer, and the actually this surface is electroless plating of silver is done, sorry, of nickel is done. This pen, a 10 rupees pen, this part, end cap near the tip is actually a plastic material coated with nickel. For coating nickel, first we have to coat palladium, and then we have to coat copper over that, and then over that we coat nickel. So this is an example for this part is an example for electroless nickel plating. Similarly, electroless copper plating is widely used in printed circuit board making, particularly in mobile phone boards, etc. We'll see that later. Electroless plating. Electroless plating implies the production of coating from solution of metal ion without use of external source of electric energy. Let us see the electroless plating bath. For example, if you want to coat nickel over a nut, uh, we have to place in a solution. No electricity is required, where nickel chloride solution is taken, and we have to take suitable reducing agent, and the metal ion get reduced to metal and get deposited over the substrate. Let us see the definition of electroless plating. Electroless plating is defined as controlled autocatalytic deposition of continuous layer of noble metal from salt to solution on a catalytic surface of the base metal by using suitable reducing agent without using electricity. This method allows easy preparation of thin films using simple equipments. Let us see the plating method. In electroless plating, plating bath contains metallic ions, reducing agents, complexing agents, stabilizer, and other components. It involves several simultaneous reactions in aqueous solution which occur without use of external electric power. The hydrogen is released by the reducing agent, normally sodium hypophosphite. In nickel coating, we use sodium hypophosphite. The hydrogen leaves as hydride ion, H minus ion, and oxidized. This producing a negative charge on the surface of the metal or plastic part. So the hydride ion produced in the solution get adsorbed on the metal surface or plastic part, and produces a negative charge on the metal surface, which aids the deposition of nickel 2 plus or copper 2 plus, um, or nickel 2 plus from the solution as nickel metal. Then key requirement of the electroless deposition bath of this type is to arrange the chemistry such that kinetics of homogeneous electron transfer from reducing agent to the metal ion is slow. We have the kinetics of electron transfer, homogeneous electron transfer from reducing agent to metal should be slow. If it is fast, it is not possible to deposit on the substrate. This is essential because otherwise the metal ion would simply reduced in the bulk of the solution. So if you are not reducing the speed of deposition, the speed of reduction, if you are not reducing the speed of reduction, the bulk reduction will be taking place. Metal powder is obtained in solution, and there won't be any deposition. So we have to reduce the speed of transfer of electron um, from reducing agent to the metal ion. See the catalyst to accelerate the we need a catalyst to accelerate the rate of metal ion reduction uh, at the metal surface or coating surface. We need a catalyst to increase the rate of metal ion reduction. This is applied to the surface to be coated. In this way, metal ions are reduced only at the metal surface, and the surface become coated with the desired metal. So we apply a catalyst on the desired surface to be coated, and we accelerate the rate of metal reduction at the surface to be coated, such that bulk reduction will not happen. Let us see the steps in electroless plating. There are three steps. First we see the stability of plating. The stability of electroless plating fully depends upon the substrate material, uh, the pre-treatment process, the type of solution used, and the pH and temperature during plating. These are the important factors which decide the stability of electroless plating. Once again, depends upon the substrate material, pre-treatment process, then type of solution used, pH and temperature during plating. Electroless plating involves three steps. First step is preparation of surface to be plated. We have to activate the surface. Second is etching, removal of impurities by acid treatment. Third step is uh, electroplating. Electroplating, some cases, some electroplating is required. Thin layer of the metal to be plated on other suitable metal to be coated on the surface. For example, if you want to coat nickel over iron, you have to electroplate nickel, electroplate copper first, then only we can coat nickel over that. So some cases electroplating is required if the part is metal. In the case of plastics, we do some chemical treatment. Plastic objects are printed circuit boards, etc., first treated with the stannous chloride and palladium chloride. Stannous chloride is a reducing agent which can reduce palladium chloride to palladium metal. Palladium is one of the noble metal like platinum. This treatment yield a thin layer of palladium on the treated surface. Palladium is a costly metal, but we apply very thin layer of palladium on the surface of the plastic or metal to be coated. Then preparation of bath. Preparation of plating bath is important. First, soluble salt of the metal like a chloride, sulfate, nitrate, etc. For example, in the case of nickel, we take nickel chloride, nickel plating. Copper plating, we take copper sulfate. If you want silver plating, use silver nitrate solution. Then complexing agent like EDTA, tartrate, citrate, etc. are used to prevent excess deposition. Then reducing agents like sodium thiosulfate, formaldehyde, etc. are used. In the case of nickel plating, we use sodium hypophosphate as a reducing agent. In the case of copper electroless plating, we use formaldehyde as a reducing agent, etc. Then exaltants or accelerators like succinate, glycinate, uroids, etc. enhance the plating rate. This accelerator is applied on the surface of the substrate to be coated. Then stabilizers like calcium ion, lead ions, thiourea, etc. prevent decomposition of the bath to impart stability of the solution. Then buffer solution like Rochelle salt, boric acid to maintain the pH. Then procedure. The article to be plated is immersed in plating bath containing metal salt reducing agent. The plating is carried out on a series of tanks. Rate of deposition is controlled by amount of reducing agent and the type of chelating agent. Chelating means complexing agent like EDTA. Then example for electroless plating, electroless copper plating, nickel plating, or silver plating. I told you about mirroring, silvering of mirror. And let us see the advantages of electroless plating. Surface to be coated does not need to be conductive. Thus, electroless plating can be made on both metals and plastics or ceramics like glass. Then electroless plating, the electric power and other accessories are not required here. Then third point is give uniform coating even the objects are irregular shape or holes in the accessories, etc. Holes and recesses, etc. Then coating provides better wear resistance. For example, over the ball bearing, we can use nickel coating. because it is highly wear resistance. Then coating is less porous and provide better corrosion resistance than electroplating. It provides flexibility in plating volume and thickness. Let us see the electroless copper plating. Electroless copper plating used to deposit a layer of copper on the substrate without use of electric energy. It is commonly used in making printed circuit board. I told you mobile phone boards are multi-layered boards which are made by electroless copper plating. We can make multi-layered copper lines in plastic boards using this technology. Is very much important in PCB making. Then the object plated is degreased first using organic solvents and then followed by acid treatment. Then this object is then immersed in plating bath containing cupric salt, reducing agent, buffer and complexing agent. Then electroless copper plating copper solution, electroless copper solution utilizing formaldehyde as a reducing agent and employ high pH at about 12 using sodium hydroxide. Then let us the electrochemistry. Copper 2 plus 2 electron give copper. The reduction potential of copper is plus 0.34 volt. The reducing agent is formaldehyde, HCHO. Formaldehyde um, in alkaline medium has potential about 0.056 volt. So this is a reduction reaction. Copper 2 plus undergo reduction, get deposited as copper metal, whereas formaldehyde undergo oxidation to formate ion. HCO minus means formic acid, formate ion, and hydrogen evolution reaction happens, and so the formaldehyde undergo oxidation. So formaldehyde is a reducing agent. And overall reaction, we sum up these two reactions, we get the overall reaction. The importance of applications of copper plating. This type of coating mainly used to make double or multi-layered printed circuit boards where plating through hole is required. For making PCBs, mobile phones, multi-layered, it is a multi-layered board. One layer has to be connected through another layer through holes. So in such such PCBs, we can apply electroless copper plating. This method, this is used base coating of subsequent electroless plating. For example, if you want to suppose you want to coat nickel over a plastic, first you have to coat palladium. Over that we have to coat copper. Over that we used to coat nickel. So subsequent electroless plating is required. We can use copper electroless plating. Then electroless nickel plating. Our syllabus, we discuss electroless copper and nickel plating only. Uh, Metals like iron, aluminum, copper, and alloys like brass can be coated with nickel. Non-metallic materials like glass, plastic, quartz, etc. Can also be coated with the nickel. First, in the case of non-metallic materials, first we have to coat with palladium using stannous chloride and palladium chloride in acid medium. So first a thin layer of palladium is coated, and over that we can coat copper, and over that usually we coat nickel. Then the pre-treated object is immersed in plating bath containing nickel salt and the reducing agent like a sodium hypophosphite. Phosphorus possesses a different oxidation state. In phosphoric acid or phosphates, the phosphorus is in +5 oxidation state. In phosphorus acid, phosphorus is in +3 oxidation state. Phosphorus acid, the salt of phosphorus acid is phosphite. Then let us see what is hypophosphite. If the oxidation state of phosphorus is +1, it is called hypophosphite or hypophosphorus acid. Hypophosphorus acid has the formula H3PO2. H3PO3 is phosphorus acid. H3PO4 is phosphoric acid. H3PO2 is phosphorus acid for hypophosphorus acid. The salt of hypophosphorus acid is sodium hypophosphate. Has to be used here, and here as the reducing agent. Nickel having reduction potential minus 0.26 volt. H2PO2 minus, it is hypophosphite ion. Sodium hypophosphite can be represented as, the hypophosphite ion can be represented as H2PO2 minus, undergo oxidation. The reduction potential is more negative here, 0.499. Only few inorganic species, only few inorganic non-metallic species possess negative value of reduction potential. Hypophosphate ion is one among them. Since the negative value of reduction potential is higher than that of nickel reduction potential, nickel reduction potential is minus 0.26, and the reduction potential of hypophosphate ion is more negative. So more negative species undergo oxidation, and nickel is having higher reduction potential when compared with this one. So nickel undergo reduction, and hypophosphite ion undergo oxidation to phosphite ion. This is phosphite. Here in hypophosphite, phosphorus is in +1 oxidation state. It is converted to phosphite, which here the phosphorus is in +3 oxidation state. Here the overall reaction is nickel 2 plus hypophosphate plus water, giving nickel metal plus phosphite. Here two H plus ions are generated. As the H plus ions are released in the reaction, pH of the solution decreases. To maintain constant pH, we have to use a buffer to maintain constant pH. Here uniform grained plating is obtained. Let us see the applications of electroless nickel plating. It is used in aerospace components for wear resistance, corrosion protection, and chemical resistivity, lubricity on valves and piston, engine shaft, engine mount, compressor blades, etc. It is used in using in packaging and handling machinery due to its wear resistance, cleanliness, and attractive finish. It is used in various applications. It also used in automobile body in various applications for various purposes. For chemical manufacturing, due to chemical resistance used in manufacturing, due to chemical resistance used in chemical manufacturing and storage equipments. In automotive mobile industry, due to wear protection, corrosion resistant, used in making ball bearing, used in making piston cylinders, gears, differential pinion, piston ball shaft, fuel injectors, ball studs, heat sinks, etc. So numerous applications are there for electroless plating of nickel. The coating is very hard, so even ball bearings can be even ball bearings. This coating is safe, and it is highly wear resistant. These are the applications of even in the beginning of the slide I have shown you a pen. Even pen end cap is coated with, can be coated, plastic can be coated with the nickel. So various applications are there. Thank you all. Thank you for your patient listening.